This clip is about viewing, or it could be subtitled Better Living Through Matrices. When I was in high school, I tried to write my own viewing pipeline, and I was mostly successful, but if I'd known how to use matrices, I probably would have succeeded. The overview for how to do the viewing pipeline is contained on page 155 of the textbook. And on page 155, you'll see a set of matrices for perspective viewing that looks like this. The big matrix M is equal to M, which does the viewport transformation, times another matrix M, which does the orthographic view projection, times another matrix P, which does the perspective transformation, times another matrix M, which does the camera transformation. So this matrix takes us into camera space. This matrix takes a perspective projection viewing problem and turns it into an orthographic projection viewing problem. And then this matrix takes the orthographic viewing problem and turns it into a viewport. And then this matrix finally sends us to the screen. What I'd like to do is talk for a minute about each one of these matrices. The camera matrix takes the world space and converts it to camera space. The camera matrix is given in equation 7.4 on page 147. You can think of the camera matrix as doing two things: moving the camera eye point to the origin and then rotating the axes of the world to line up with the axes of the camera. We'll have more about how to build the axes for the camera later in a different set of notes. The matrix P can be found on page 152, and its purpose is to project each point in perspective space onto a viewing line in orthographic projection space. This is explained on figure 7.13 in the textbook. Explains what the matrix P does. The orthographic projection matrix simply does an orthographic projection onto a viewing plane, and it can be found on page 145. It's where you can find the orthographic projection matrix. Finally,